Let's begin section 3.2, solving linear program problems graphically. We're still going with the inequalities. Of inequality functions to demonstrate strengths. And we're going to discuss that more clearly as we apply all that we learned on inequalities and overlapping possibilities in this section. So here we go with vocabulary. Linear programming, okay, is the construction of inequality of linear functions to describe availability of resources and cost constraints. All right. And then from that, a z function is included. Actually, it's not a function. I should change that. A z equation is constructed to find optimization. Production. Products or other constraints. So it's an equation and it says z because we don't know what it is, but we do know that from the constraints we can find the optimization. So let's talk about the parts of this. All right. The objective function, and they call it a function because it's three variables and you can put anything in there. So the objective function is the z equation. That represents optimization of what is produced right, and it has to find minimum costs or maximum costs. Minimum. I can't spell. And in this case, it's usually revenue. All right. So we have this Z equation. We got a whole bunch of inequalities, and we call those the constraints. The inequality functions that describe the constraints of labor, material, shipping, etc. Boxing, all of that, etc. The company. Inequalities, and that means less than or equal to, greater than, or greater than equal to. These are those functions that we did in section 3.2. So now we're going to talk only about the constraints of the graph that are given from the inequalities, and then we're looking at two optimization objective functions. So these two objective functions, we're going to find the maximum and the minimum for each of them. Now, we don't know what they are, but we're going to figure it out. And what we need to know is the points, the bounded region points that are going to be used in the objective function. And we need these points because these are vertexes where all of the constraints intersect. Points of intersection of the constraint functions. And of course, I'm talking about inequalities. So they've done the work for us of graphing and identifying. So all we have to do is recognize the vertex points. And the points are 2 and 5, 0 and 4, 6 and 3, and 4 and 1. So these are the ones we're going to be looking at for those objective functions. So we're going to start first with our z equals 5x plus 4y. And we're going to use our points. Right. So our points were 2 and 5, 0 and 4, 6 and 3, 4 and 1. Now, you would think that the one that's the largest, right? But that's not always the case of what we want. So we're going to be doing the function. All right. So we have here z equals, and it's going to be 5 times the 2, because that's the x value, 4 times the 5, because that's the y value. And now I'm going to need some space on it. So now I'm going to have z equals 10 plus 20, and that gives me 30. So for this problem, the number is 30. So we're going to do the next one. Same process. Z equals 5 times 0 plus 4 times 4. Well, this is z equals 16. And we did that one. Now we're going to do the next one. And we're going to have z equals 5 times 6 plus 4 times 3. And this is 5 times 6 is 30 and 12. So z is 42. Our last one, z equals 5 times 4 plus 4 times 1. So z equals 20 plus 4, 24. So these are all the outcomes for, for our objective functions. All right, now let's answer the question. The maximum value of the objective function z equals 5x plus 4y is, and our biggest number is 42, and located only at the point, and see, who would have thought that, 6 and 3. Well, those were the biggest one thing. All right. The minimum value of the objective z equals 5x plus 4y is, okay, in this case, we're looking for the lowest number, and it looks like 16. All right. So we're saying that 16 at the point 04. So now we're saying the next objective. Notice we did all of them for that value, for that objective function. Z equals x plus 7y. So we're going to have our points, and then our z equals x plus 7y. And we're going to do the 2 and 5. So z equals 2 plus 7 times 5. Z equals 2 plus 35. So we've got a whopping 37. Now we're going to do the point 0 and 4. So z is going to be 0 plus 7 times 4. Z is 28. And we're doing the third one, 6 and 3. So z equals 6 plus 7 times 3. That's 21 plus 6, 27. Now we're at the last one, 4 and 1. Z equals 4 plus 7 times 1. Z equals 4 plus 7, and that's 11. All right. So let's answer that group. The maximum, all right, so now on this one, let's look. We have 11, 27, 28, and 37. The maximum on this guy is going to be our 37 at the point 2 and 5. The minimum for this function would be the 11 at 4 and 1. All right, now this was an exercise of what we're expected to know and do for this assignment. So let's continue on and see what we've got. All right, we've got another one, and it's got constraints. I'm not going to go into the whole detail of everything, but we're going to talk about our values. So our points are, and those are the vertexes, and it doesn't matter how we write them, just so long we write them. 0 and 2, 5 and 8, 8 and 3, 9 and 0, and 0, 0. And you're saying, well, that's kind of silly. Well, sometimes it happens to be a consideration, but as to being a minimum, I guess, and kinds of things. So as we look at this problem, we're going to do the same constraints, and they gave us decimals. So we might use our calculator a little bit to ensure the math is correct. All right, here we go. Let's read the problem. The graph to the right shows a region of feasible solutions. Use the region to find maximum and minimum values of the given objective function and the locations of these values on the graph. So let's find that. Let's do the math. So we're going to start with our A, which is z equals 5x plus 3y. And as we work these, we can see all of the regions and how it affects what we do with them. All right. So in this one, let me see if I can get it a little bit thinner. Well, no, it's all right. So we're going to do our points, and then we're going to do our function. Right, here we go. 0, 12. Right. 0, 12. So I'm going to have 0 plus 3 times 12. Z equals 36. That's that one. Then I'm going to do 5 and 8. So my Z is going to be 5 times 5 plus 3 times 8. I'm sorry, can't multiply, can I? 25 plus 24. Z equals 49. All right, that looks promising. Larger than the one we just did. 8 and 3. And in 8 and 3, I'm going to have Z equals 5 times 8 plus 3 times 3. Z equals 40 plus 9. Z equals 49. There you go. Right, then I have 9 and 0 equals 5 times 9 plus 0. That's 45. Not shabby at all, is it? And of course, R 0, 0. That means we don't do any work. So that's 0, 0. All right. So let's answer about that. And I'm going to make it smaller. There you go. The maximum value of the objective Z equals 5x plus 3y is, okay, 36, 49. I have two 49s, 45 and 0. So What happens here? Well, we've got two of them. So we're going to say 49 are located on pointer points, and one of them is 5/8. So the company has choices of which one to use, and the other one is 8/3. All right. The minimum of 5x on a 3y, of course, is 0. That is a minimum. Kind of silly, but yeah, could be. Well, it might be cheaper not to do anything, correct? Could be. So let's look at this next one. This one is 2.5x plus 2500ths y. All right. So we're doing our points. Our first point is 0 and 12. So z equals 0 plus a quarter times 12. All right. I'm going to use my calculator here. Minute to move it a little bit. Just a minute. Oh, sorry. Should have done this before I started, I know. But, cantankerous. Let me move it over here. So, we have on this guy, clear out what I've worked on before, 0.25 times the 12. And I get half. Oh, didn't do 12. This next one is the 5/8. So z equals 2.5 times 5 plus 25 times 8. That looks like 2 there. Oh, look at that. What did I do there? It should have been a 5. 2.5 times 5 and 2500ths times 8. Now I can enter. My next one is 8/3. .5 times 8 plus 0.25 times 3. 2075. Our next one is 90. So z equals 2.5. I bet this one is the big one, plus 0. Right, for the max, 250. All right. And of course, our 0. Right. So it says on this one, the max is, we're right, 2250. At only 1.83. The minimum is 0 again. I put the wrong number there. Thank you. That's 90. I apologize for that. And our minimum again is going to be, it looks like 00 again, not even working. Kind of meaningless, isn't it? Yeah. All right. So now we have another one that's an inequality. This is unbounded. And so we're going to do this one as well. And there is a maximum. Is there a maximum value for objective z equals 3x plus 5y? And the answer is no. It is unbounded. We have a minimum. The minimum value of the objective, and we do have that because our points are 0, 9, 1, 4, 5.5, and 2, and 3. Oh no, that's 13. Sorry about that. My eyeballs. 13 and 0. All right. Those are the lowest because it's unbounded here. Okay. So those are our points. And now we're going to work at it. So we're looking at least we don't have a 0, 0, right? Okay. We're looking at z equals 3x plus 5y. Z, which we're going to do the first one, 0 plus 9 times 5, 45. All right, that's 1. Now I have z equals 3 times 1 plus 5 times 4. 3 plus 20. That's a 20. 23. All right. We're going to do the next one. Z equals 5.5. Let me make sure that was what I saw. Yes, 5.5. Actually, we're going to use a calculator, so it doesn't matter. 3 times 5.5 plus 5 times 2. All right, so we're going to stick that in the calculator. Right, I'm going to have 3 times 5.5 plus 10. 26.5. Right, so now I'm at, I'll put this over here for now. I'm at 13 and 0. 3 times 13 plus 0. This is 39. All right. So we had, let's review that I didn't forget any numbers. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now we're looking at the numbers and we're saying 23 looks like the lowest. At the point 1, 4. Is there a max? No. Again, it's unbounded, but there are minimums. And now we're using for z equals 4x plus 9y. All right. And we will be using our first point, which was 0, 9. 1. Now I'm doing 1 and 4. Looks like 40. Right now I'm doing 5.5. Definitely calculator, right? All right, let me get my calculator out. 38. The last one, C equals 4 times 13 plus 0. All right, now we know we don't have a max because it goes to infinity unbounded, but we do have a minimum. And the lowest between these four right here looks like 40. And it's located at the 0.14. And of course, there is not. It's unbounded. So we're looking at the minimum for, in this case, we're talking z equals 2x plus 4y. All right. So we're going to do a point, let's see, what was our first point? 0.09. So now we have z equals 2 times 0 and 4 times 9. So z is 36. All right. So now we're going to do the second point, which is 1, 4. So z equals 2 times 1 plus 4 times 4. That means z equals 2 plus 16, 18. That looks pretty low. Our next point is 5.5 and 2. Z equals 2 times 5.5 plus 4 times 2. We'll just use the calculator. Right, and I'm going to say 2 times 5.5 plus, oops, 4 times 2. Oh, let's see what I messed up on. Oh, silly me. I keep on, let's just erase it and I'll do it again. 5.5. Sometimes it's picky with my pen on the simulator. There we go, 19. And we have our last point here, which was 13 and 0. So z equals 2 times 13 plus 0. 26 it looks like. Okay, our minimum is the 18 at 1, 4. All right, and this is a no for that next one. And now we're doing the last one. Z equals x plus 2y. All right, so I've got my points. 0 plus 2 times 9. I get 18 on this one. On the 1, 4, it's 1 plus 2 times 4. Oh, look at that. Z equals 9. That looks promising. Okay, this one is going to be 5.5 plus 2 times 2. So Z equals 9.5. This is 4 onto the 5 is 9. I'm doing the last one. Z equals 13. Ha, that's that one. Okay, so my lowest is 9, and at 0.14. So they all congregated, whatever they're studying, congregated there. All right, guys. This completes what I want you to understand. It's looking at Z, and later on we'll work further in that concept of optimization. Thank you very much for listening. Do your homework after you've taken notes.